All right, so section 13.2. You guys are not going to have homework over this until Monday night. Okay? Yeah, I'm not giving you homework over the weekend. I don't want to work this weekend, so I'm not going to make you either. All right? So, but you will have a homework assignment from this lesson Monday night. All right? So, slope of a line. This whole lesson is teaches us what the slope is, what it means. And we're going to look at it in two different ways. We're going to look at slope on a graph, and we're going to look at slope with ordered pairs. All right, so this diagram looks like really crazy, right? You're like, okay, I recognize these words, but what is going on here? Slope, in a nutshell, is a rate of change between two values. It's a rate. So slope is a continuous relationship between x and y. All right, so when this happens to x, then this will happen to y, basically. So different operations. So how do I find slope? Slope is calculated by measuring a change in my y values between 2 points divided by a change in my x values. We call this rise over run. So you're going to hear me saying that a lot today, rise over run. And then also, when I'm dealing with ordered pairs, I want you to circle this formula. I want you to star it. If you were to ask any one of my 8th graders right now on the spot, did anybody ask one of the 8th graders slope-intercept form? Did y'all put them on the spot yesterday? Okay, they better know this formula too. Did you? Did they know it?
No.
What?
Yeah.
Oh, that's such a shame. I don't even want to know who it was. Okay, they should know the formula to find slope. All right, so it's kind of catchy, but I want to say it together. I want to read it together. All right, so m equals y2 minus y1 over x2 minus x1. The change in your y values divided by the change in your x values. You'll see more of that in just a minute. So what am I looking at here? All right, well, I can have a positive slope. I can have a negative slope, a slope of 0, or an undefined slope. We always read slope from left to right, okay? So when I'm looking at this line, all right, let's look at the positive slope. I'm looking at it from left to right, okay? Because you could say, well, you know, this line, it says it's positive, but if I read it from right to left, then it's negative. You don't read it backwards. It's like reading pages from a book. You would never read them right to left, okay? So we always read a graph from left to right. And we'll talk in a minute about what, a little bit more about positive and negative slopes. Okay, so that's the rundown. That's the overview and what I'm looking at when I calculate slope. So how do I find slope with a graph? If I have a line on a graph, I can measure the distance between 2 points and write it as rise over run. Rise over run. So I want you to write that down just somewhere around point A. M equals rise over run. Rise over run. This is my change in my rise. So which value, x or y, do you think stands for rise? Rise is your y value and run is your x value. You will never run backwards, okay? So if your slope is negative, that's because your rise is negative. We'll look at that on point B. So point A highlights, so let me switch this, highlights a rise of 5 units. So from my first point on the far left to my second point, I'm going to rise 1, 2, 3, 4, 5 units to make it even with that second point. So that's what it's saying. And then I'm going to run 6 units. So that's why we see a 6 written down there on the bottom, because I go 1, 2, 3, 4, 5, 6 units over to get to my second point. So all you're going to do is write that into a fraction. I rose 5 units and I ran 6 units. Can that be reduced at all? 5 over 6. Nope, can't be reduced. So that's my slope. All right, so let's look at point B. I just want you to look at the line for a minute. So on point A, my line went from left to right and went up. What do you notice about point B? It goes from left to right, it goes down, okay? So that means that my slope is going to be negative. But remember, my run is never negative. My line is moving forward, okay, on the x-axis. My rise is what is negative. So that's what I see here with a -3. All right, that I'm going down 3 from left to right, and I'm going over 2. So one of the biggest challenges with writing slope is that you remember it's rise over run, not run over rise. All right, so don't get that switched up because it does matter. So -3 over 2. M equals -3 over 2. All right, any questions on reading a graph? You guys have any questions on that? Okay. So now I want you to try to calculate your slope. All right, pay attention to the direction of the line. Is the line sloping down or is the line sloping up? That affects the value of your slope. All right, so we're going to do rise over run. All right, so M equals my rise over my run. When you have the slope, I want you to turn to a neighbor and compare your answers with each other. So we'll just pause here for a sec. All right, guys, what was your rise? Somebody raise your hand and tell me, what was the rise, Julia? -1. So between the 2 points, I go down 1, and Sebastian, what was the run? 1, 2, 3, 4, 5. So did you say -1 over 5? -1/5. Yeah. So this is the rate of change. Here's what I need you to understand. If I wanted to go down another point from the second one, guess what I would do? I would go down 1 over 5. And I can plot another point. Guess what I would do if I wanted to plot another point after that? I'll give you one guess. Down 1 over 5 again. What do you think happens on the next one?
You do the same thing over and over.
Okay, are you getting the point? Yeah. So the slope is a continuous rate of change. It's the distance between 2 points, basically.
Is this negative?
It is negative, so it's going down. That's why my slope is negative. All right, so what do I do if I don't have a graph? All right, there's a faster way. So don't you guys like the fastest way, especially in math?
Yeah,
okay, so I'm not going to make up a graph and plot the points on this graph so I can count the rise over the run. By the time you get done with that, I could have done 3 of these problems. Especially the more that you're going to get quicker at this process, okay? You'll get to the point where you can calculate slope in your head pretty easily with ordered pairs. But in order to get there, we have to start at the beginning. We need a sequence of values. I have to know within these 2 ordered pairs what sequence stands for which symbol. All right, the sequence is always the same. It goes x1, I want you to write this down, x1, y1, x2, y2. All right, now here's why. And I'm only going to explain this one time, but I do think that it's important that we understand. This is my first ordered pair in the set, okay? The first number in the ordered pair is an x value, right? It goes x and then y. So that's why it's x1, y1. x2, y2 just means that it's the second x value in the set, right? So that's why it's x2, y2. So why does this matter? Because my slope formula, and I want you to write it down, says that I can subtract y2 minus y1 over x2 minus x1 to get my slope, or my rate of change between the 2 points. So why do you think you would subtract y2 minus y1? Why do you think you would go backwards like that? Think about the graphs that we just did. Okay? So because didn't we start at the first one and we counted rise over run? So to find the difference, I have to work my way backwards to subtract them. Okay? So that's why it's y2 minus y1. So which value, according to my sequence, is my y2 value? 6. All right, so you're going to plug in 6 for y2. Minus, so the minus sign is a part of my formula. It does not matter what the value is, the minus sign is there. So what is my y1 value? Negative 4. You're going to see this happen a ton with slope. That you minus a negative, and a double negative changes to a positive. All right? Over, what's my x2 value? 2 minus 6. All right, so now I'm ready to simplify. What's 6 plus 4? 10. And what's 2 minus 6? Negative 4. All right, now here's where, is this a fully simplified fraction? Okay? It's not. You cannot make it a decimal, though. You cannot make it a mixed number because you need it to stay rise over run. How would you know how many to rise and run if it's a decimal? So, but you can reduce it. What factor could you reduce this by? 2. So it becomes m equals 5 over 2. What? Yes. What am I forgetting? The negative. Where does the negative need to go? No.
The whole thing.
It can be the whole thing. When my slope is negative, that means my rise is negative. You say, but 4 is what was negative. I understand that, but remember, when it comes to the sign of a fraction, you can put the negative in either the numerator or denominator. This means I have a negative slope, but you have to remember it's your rise that is negative, never your run. Okay? Okay, so let's do the next one. M equals, all right, which number is my y2 value? Which number is my y2 value? According to the sequence, x1, y1, x2, y2, 5. Minus, which one's my y1 value? 8 over negative 4 minus 4. So what's 5 minus 8? Negative 3. And what's negative 4 minus 4? Negative 8. So negative 3 over negative 8 becomes positive 3 over 8. Because 2 negatives cancel out and make a positive. All right. Any questions on finding slope with ordered pairs using our formula? Okay. Let's see. Finding slope. Okay. All right. So now we're going to do the same formula. All right. We'll do the same formula, y2 minus y1 over x2 minus x1. But now something different is going to happen with my slope.
No, we only have one of the ordered pairs.
You only have one of them? Okay, you can just write the other one in. Thanks for letting me know, though. All right, so let's just write down the sequence again to practice. x1, y1, x2, and y2. All right, so which one's my y2 value? Negative 2 minus what? Negative 2. So there's that double negative again. Over, what's my x2 value? 7 minus 1. All right, so what happens to my double negative? Changes to a positive. What's negative 2 plus 2? 0. What's 7 minus 1? 6. And if you look back to the original ordered pair, so Julia, this is kind of along the lines of what you were just talking about. you can tell that your y value isn't changing any. Between the two ordered pairs, your y value is -2, right? So I want you to try to visualize if you were to plot these 2 points, okay? On the first ordered pair, you would go right 1, and then where would you go? Down 2. Plot your point. Where would you go on the second ordered pair? Right 7, and then where would you go? Down 2, and you would plot your point. So when you connect those points, what are you going to end up having? A horizontal line. What you need to remember is that a horizontal line has a slope of 0. 0 will be in the numerator, meaning there's no change in my y value between the points. This is important, okay? Because when we look at the next problem, something different is going to happen, and it changes the value of my slope. So let's look at the next one. All right, can we say our formula together? M equals y2 minus y1 over x2 minus x1. So let's plug in our numbers. Y2, -5, minus y1. Which number is y1? All the other numbers are the same. All right, which one's y1? -3, so that's a double negative, over x2, which is also -3, minus -3. Lots of -3s. What happens to my double negatives? Changes to positives. Okay, and what's -5 plus 3? -2 over what's -3 plus 3? 0. Now 0 is in my denominator. Okay, I want you to think about these two ordered pairs if they were to be graphed. Both of them go left to an x value of -3. One of them goes down to a y value of -3. The second point goes down to a y value of -5. But both of them are on the same x value. So what kind of line is this one? I'm doing the motion. Okay, it's a vertical line. So when 0 is in my denominator and it's a vertical line, remember, slope is some kind of horizontal slant. So when it's a vertical line, my slope is undefined. If you have 0 anywhere in your slope, you cannot keep it a fraction. You must tell me if your slope is 0, meaning the 0 was in the numerator, or if it's undefined, meaning your 0 was in the denominator. You've got to take that extra step, all right? If you leave it in a fraction, I don't know if you know if your slope was 0 or undefined. Does that make sense? Just kind of nod or thumbs up. Okay. All right. Let's see what we got next. All right. So this is pretty simply put, but it's just the different view of it. What kind of line do you see on A? A horizontal line. What do we say about the slope of a horizontal line?
0.
It is 0. So the slope, you're going to say M equals 0. It is as simple as that. You don't have to do rise over run. You don't have to do any of that jazz. Okay? What about B? M equals undefined.
Oh, wow.
No rise over run. You just recognize a vertical line has an undefined slope. Okay? All right, any questions on that? We just have to show you both ways. That's what 0 and undefined slopes look like with ordered pairs and with graphs. Okay, parallel lines. Do you guys have this example in your notes? Okay, so if two lines are parallel, their slopes will be exactly the same. Okay, so think about it. Parallel lines never do what? What do they never do? They never cross. So in order for them to never cross, they have to be slanting exactly the same way. The same rise and the same run over and over and over again. Does that make sense? So I can compare lines to see if they're parallel by comparing their slopes. We're going to do that on this graph. I want you to find the slope of the blue line. Oh, that was bad. All right, blue. I want you to find the slope of the red line. And I want you to find the slope of the green line. All right, what was my slope of my blue line? What was my rise over my run? What was my rise over my run?
-2.
For blue, it's going up, girl. It's going up, right?
Wait, what? Okay.
So my blue, what is my rise? I go up 1, 2, 3, 4. And then I go over how many? My blue line is 4 over 1. What was my red line? 5 over 1. So are those two lines parallel? So green will probably be parallel to one of them. What was green? 4 over 1. So which two lines are parallel? Blue and green are parallel. Blue and green are parallel. All right, any questions? Okay. All right, so now I need to determine if the equations are parallel. So I looked at, okay, are the lines parallel on a graph? Now I need to look at, are the lines parallel in an equation? What did I just say has to be true about the lines if they're going to be parallel? They have to have the same what? They have to have the same slope. We've been using the variable m in today's lesson. What does m stand for? M is the slope. Okay? So here's, I don't know. Someone in Aristotle made it up, or somebody. Okay? Here's a familiar formula from yesterday. Y equals mx plus b. There's that m again. Now you know what m stands for. M stands for what? Slope. Meaning that the number in front of the x, as long as it's written in slope-intercept form, is my slope. So to prove if they're parallel, you're going to simply see if their slopes are the same. All right, so in this line, are their slopes the same? Okay, so we're going to learn how to graph in slope-intercept form possibly next week. But what you need to understand for now is that that number tells me I'm rising 3 and running 1, 3 over 1, on both lines. So because of that, these are parallel. Both slopes, or you could just say m equals, are 3. When you say 3, don't say the same. I want you to tell me the value. I know that you knew what to look for. Okay? If you say both slopes are the same, well, I mean, are you guessing or could you really tell? All right, so tell me what the value is. There's a challenge on the next one. I believe, is this the last one or do I have one more after this? I skipped a few. Okay, that's okay. We've covered most of the content from this lesson and we can make up on Monday anything that we missed. This is going to be our last problem. I can't compare these yet. And this is going to be a tie-in to what you learned yesterday. I can't compare these because both equations are not in slope-intercept. Is my second one solved for y? Yup. Is my first one solved for y? Where would my heart go? It goes over 2y. Okay? what would I do next? I got to get y by itself before I can compare my slopes. What would I do next? What do you guys think?
You add 6x to 18.
Yep, you need to add 6x to the other side, just like we did yesterday. And then we bring everything down, right? We cannot combine 18 plus 6x. They're not like terms. 2y equals 6x. Is it plus 18 or minus 18? Plus 18. One more step to get y solved for. What do I do?
Divide everything by 2.
Y equals 3x plus 9. So the first equation, what's my slope?
3.
Okay, 3. The second equation, what's my slope?
Negative 3, sir.
Okay, so this is no. All right, so no, they're not parallel. You could say m equals 3 and, don't do a comma, do like an and symbol, and negative 3. So that way you're telling me it's no because I recognize my slopes are different. All right, any questions on that? Okay, so we're going to end here. I think we've covered enough content for today. Our Friday brains are kind of fried. We'll finish up the lesson on Monday. Like I said, you're going to have your homework assignment Monday night from this lesson.